Now just pay attention to this one of the Amazon architecture, that is a geographically separated, and it is a physical infrastructure. It has a geographical region, availability zone, and age location. So go ahead and review this for a quick minute, and then I'm gonna explain it each component, how this architecture is written. So when you take a look at this example, you can see multiple things, right? If you just pay attention, this is your application, and this entire is the cloud infrastructure. So you are using the RDS for the database part. You are using the EC2 instances with the auto scaling, elastic load balancer, and the CloudWatch. Based on the CloudWatch metrics, your auto scaling would kicked off. Then you have a EBS volumes that's also cross region replicated. Then you have a virtual private cloud. That means you can create your instances in the cloud environment, that is a virtual network. You are using Amazon SQS. You are using simple notification topics. You are using simple DB domains, and you are using the Amazon CloudFront, right? So that's the Amazon CloudFront. So elastic IP address. So if you just think about all these components, we have already worked through all of this, right? Simple DB, RDS. So these are all the things that you can do using this Amazon architecture. Let's just go ahead and review it with the best practices that's out there. Go ahead and review the important ones, right? Like for example, Amazon database services. What are the functionalities? Simple queue, Amazon Elastic Map. So go ahead and review this, all these best practices components that are out there with Amazon. Go ahead and review the Route 53. There you go. Go ahead and review all those things up to the IAM row. All right, let's just move on to the next task. Cloud concept. The most important thing over here is how do you build a scalable application? It is critical to build the scalable application or architecture in order to take the advantage of scalable infrastructure. The cloud is designed to provide the concept of infinite scalability. However, you cannot leverage all the scalability if your infrastructure or architecture is not scalable. So, what is a truly scalable application? It means a scalable service that is operationally efficient, it is resilient, and it is capable of handling the load. Increasing resources results in proportional increase of a performance. So now, how do you truly achieve a scalable application? What is the way you can take advantage of this cloud application that is scalable across the board? Now, there are multiple things that you can make to create a scalable application, like infrastructure wise, like data wise, like you can manage the cloud front, right? These are all the things that you can use to make things scalable. Understanding the elasticity. Let's just take a look at this one over here. So pay attention to this diagram. Predicted demand is this. The actual demand always varies. Scale up approach is this. It's gonna cost you higher expenditure. Traditional scale out approach was this. And automatic elasticity. So as your load is increasing, your infrastructure is also scaling up. So that's the big benefit of using Amazon. So go ahead and pay attention to this diagram right now. So as you can see the things, it allows you to traditionally scale out with as your load is increasing. The on-demand and the elastic nature of the cloud infrastructure enables the infrastructure to closely align with the actual demand. That's the biggest benefit. So whatever is your demand for the cloud right now, your elastic cloud computer or your storage, it's gonna increase itself. So that means, let's say if you spin up a EFS drive, okay, let's just say you create the EFS for now, elastic file storage. Just click on create file system, click next step, click next step, there you go, and click create a file system. So this file system is completely elastic for you, and that's why we call it as an elastic file system, right? So that it can grow and it can shrink automatically depending upon how you handle it, right? So you can just delete it for now as well, right? Just enter this ID and just go ahead and delete it. There you go. We created it. So just think about it, how easy it is to create any resource and how easy it is to terminate any resource. So go ahead and create this elastic file system in your computer or EFS and then delete it out. Try out in your computer too right now. You just have to click create and set up all the rules and create the elastic file system. That's all you are doing right now. All right, let's just go to the next thing now. Cloud computing streamlines the process for acquiring necessary resources, and there is no longer any need to place order ahead of time. So whenever you require to use the infrastructure, you can just put a request and your infrastructure would be ready. Within like 3 or 4 minutes, it's gonna be provisioned. So you don't have to worry about any other thing, right? Your infrastructure would be available right away with this approach. Instead of cloud architect can request more than what they need per minute before they need it, automate the procurement process, taking the advantage of vast scale and rapid response time in the cloud. So that means you do have an option to set up all the rules and everything. So in case you can configure that if my instance usage goes above 100% or 80%, then just spin up a new EC2 instance. That way, it's just going to work perfectly fine. It's gonna initiate, it's gonna automate that entire process. If you cannot embrace the change of elasticity in your application architecture, you might not be able to take advantage of the cloud. So cloud is just about the advantage of elasticity. If again, if you are not requiring to use all that, that means you are not taking a true benefit of the cloud computing, right? Or elastic storage. That's what you have to be clear about, because that's the whole point of cloud, that it allows you to scale up and scale down as it requires. You can also design the intelligent elastic cloud architecture so that the infrastructure runs only when you need to. And it's art of itself. Elasticity should be one of the architectural design requirement or system property. Questions these to ask: what components or layers in my application architecture can become elastic? What will it take to make that component elastic? What will be the impact of implementing elasticity to run my overall system, right? So these are all the things that you have to be aware as the cloud architect. Now, if the cloud does not provide you the amount of RAM in a server, try using the distributed cache like a memory cache across the data multiple server. If your database needs more IOPS than you have, then the recommendation is choose the type of data and the use case that supports that. So let's just take a look at the one approach that supports this one. Okay. So if your just say AWS instance type, so depending upon your requirement, what kind of instances you are going to use. If your requirement is more like a memory bound, then there you go. So this shows a memory, this shows a storage. So these are all your general purpose, and there are features here as well that you can utilize. These are M4s, these are all general purpose. Look at the compute optimize. So go to this website right now, awsamazon.com ec2/instance type, and review all the available resource types right now. You just have to review each and every available instance type that's out there and see which one you are going to use and when. So go ahead and review different instance types, storage optimize, compute optimize, and see list of things that are available, right?